Alright, hello everyone, welcome back to the channel. So we got a video here. It's been a while since I put out some videos, so I figured I'd update you on what I've been working on here. So I've got a project over here that I was working on, and that project's for another video. And I was using this spectrum analyzer to do the work. As you can see, it's on, but no display. That's going to be for another video as well. What this video is going to be about is this. So this is my workaround for this spectrum analyzer having no display right now. And we'll take a look at this and see what I needed to do to modify this so that we can turn this into a true XY display for the spectrum analyzer. Alright, so what you need to know before you want to take on a project like this is these sorts of displays with the cathode ray tubes produce a lot of high voltage. The anode here, this red wire, is about 11,000 volts, which is exposed down in this portion here. The cathode of this CRT display needs about 2,700 volts. So there's a lot of high voltage in this supply. Plus, you've got your regular mains line voltage here in this portion, because this is a switch mode power supply coming into here. So if you're going to attempt any of this work on your own, you need to make sure you take special precautions for working around this type of equipment. Now let's take a look at this this monitor here. So what this is a Tektronix. It's a 1720 vector scope. And I believe what these were originally intended for was in the broadcast industry. They would be set up in racks with the broadcast equipment so that the engineers could monitor the broadcast signal and make sure that all of the color signal levels and the sound, all the different components of the old analog video broadcast signals were set up correctly. And this the graticule here on the display, as you can see, has a pattern put into it, and it's set up with different targets, and this would be displaying vectors or lines on the screen, and depending on where they landed within the targets, the engineers could take that information and determine whether or not all of the different signal levels were set up properly, and then they could make adjustments as they needed to. These things can be found pretty cheaply now because a lot of this technology is no longer used with just the way that TV broadcasts are done now. A lot of it's computerized, it's all digital. So this is a whole different format now on that. I'm not going to go into it now, but suffice it to say, these a lot of these type of equipment is obsolete, and they're dumping them, getting rid of them. And I think, I bought this off of eBay about a couple of years ago, and it was fairly cheap. Maybe I paid like $30 for it, just because, like I said, it's just people are just getting rid of these things. And but the reason that I needed to pull this out is I needed to use the XY mode to get XY signal from this spectrum analyzer. This is a HP 3585B spectrum analyzer. You've seen this in some videos I did a little while ago where I had to repair a video problem with this spectrum analyzer. I'm having to make more repairs to it. And as I said before, those repairs, I'll cover those more in depth when I receive all the replacement parts for what needs to be done with this to get it working. But anyway, so we're going to take a look now at this vector scope here. Now it will take XY or vector inputs, and I'm going to show you more detail about that in the service manual. Well, let's take a look at some of the modifications that have been done. First off, you see that there's a push button here, and this is for an automatic CRT dimming circuit. When I push this button here, the CRT will light back up, and that's just on a delay. It's about a 10 or 11 minute delay, and it's just a little NE 555 timer circuit down here with a relay. And What that does is after the delay, it'll pick up this relay here, and it'll basically put a resistance across the intensity VR here, and that causes the intensity to drop down, which is what we saw there. And when you hit the reset button, it lights back up and resets the delay, and it starts all over again. So just a little bit of a screensaver, sort of CRT dimming circuit there. Some other things added to this is we've got a little amplifier module here, and this is to amplify the level of the X and Y input from the spectrum analyzer. What I found was driving the monitor here from the scope, from the spectrum analyzer signal levels, just you know, as they were coming out of the spectrum analyzer, they weren't large enough to get a full-scale deflection on the CRT here, so I needed to amplify them, and we'll look at the schematic for that in here in a little bit too. It's pretty simple. It's just a TL074 quad operational amplifier, and I've got some trim pots here for offset the signal level, so that I could get the signal level to sit properly in the CRT window. On the back of the vector scope, I've used these B&Cs here. These are for an external reference originally, and that's been disconnected now and set up for X and Y vertical and horizontal inputs. I've got some potentiometers here to adjust the level, and some switches down here that will switch from high gain to low gain. We'll look at that, and then a switch over here which is set up to what the switch does in this position. It uses this amplifier in line, and when it's switched to the other position, it bypasses this amplifier in case I want to drive something other than the spectrum analyzer, and I don't need the additional amplification of the signal levels there. All right, here's a look at the schematic, or a portion of the schematic for this this Tektronix 1720 vector scope here. And this portion is particularly important because it covers the sections that we need to look at. So as I mentioned before, this scope, this vector scope does originally have the capability for XY inputs, but they're not as easily accessible. Where they come in from is they come in through a 15-pin connector, just like this right here. Actually, this is a connector that I removed from the vector scope there. And what the manual says that this XY display is for monitoring stereo signal levels. I assume as part of the audio portion of the broadcast signal would come in through these channels here. But coming through this 15-pin connector here. And what it does is it goes through some operational amplifiers here. There is a high gain option here, which is set up through some jumpers that are internal to the board. We'll look at those in a minute when we have another look at the scope. And those can be set up. And what I've done for my modifications is I've just installed these jumpers, and then I use the toggle switch on the back, which switches the input from the input from the normal low gain input to the high gain input, which is down here. So that toggle switch just switches back and forth, and it does the same for both the Y and the X channels. But they go through amplifiers here. They go through another set of amplification here. There's gain control pots. We'll look at those. I had to tweak those a little bit to get my levels, my display where I wanted it. And then it goes through a switch here. This is a digital switch in the vector scope, and this is what's used to select between XY mode and vector mode. Of course, we want this to be in XY mode, and that's controlled by this push button right here. From there, it goes to the deflection, the X and Y deflection amplifiers here, and then onto the CRT, the deflection plates. So that was to the, this one goes to the horizontal deflection plates here, and then to the vertical deflection plates there. All right, looking at some of the construction details here, as you can see, I didn't go very fancy with this. Just built these boards on some of this breadboard material here, and just mounted them to some existing standoffs. There is a for these vector scopes, there's another board that goes in here for the 1720 SCH, which does some additional signal processing, and I believe that board goes on this part here, and that's what these standoffs are for. But this model doesn't have that board, so I just use these standoffs for mounting these extra boards here. All right, so we'll take a look at this amplifier here. So this is an amplifier for the X and Y channels, and then we've got trim pots here that will allow me to adjust the offset to get the signal, the video display in the CRT window where I wanted it. What I found was for the HP 3585B, there was some offset, and that caused the display to mainly just reside in this portion of the CRT here. So I had to put some offset adjustments in, and that would allow me to bring the signal up and over so that it occupied the whole CRT display. And the circuit here is very simple, and I've got it drawn here on this notebook here. Essentially, it's a quad op amp. It's a TL074. I used almost the identical circuit from the service manual. This circuit here, I basically just essentially copied this circuit. As you can see, it's pretty similar to what is here. The only difference between the circuits, or the major difference between the circuits here, is I adjusted the resistor values here to get some additional gain. So this is a 3K and a 22K resistor, as opposed to here they used a 3K and a 10K. So a little bit more gain in this amplifier here. And this amplifier here is just to invert the signal back, because you'll have inversion here, and this is to get it back to the correct reference here, so that otherwise your video would be upside down. And then here is the offset network here, using off of the negative and positive 15 volts supply, and then some resistors here that I chose. They're a little bit different for the channels, basically to give me the adjustable range that I wanted to have for the HP spectrum analyzer specifically. Like I said, if you're going to build this or modify this vector scope for your use, you may want to breadboard this out and then tweak these values here to give you what you need for the signal that you want to display. But other than that, it's identical. Both channels are identical here with the gain values for the op amps. And I used the this says plus or minus 15 volts, but what I actually ended up using was the plus or minus 12 volts off of the digital board here. I found that it was had a much cleaner signal. What I originally did was powered it straight off of the output of the power supply, and since this is a switched power supply here, there's a lot of noise on those plus or minus 15 volt rails, and that noise carried in to the amplifier and then into the signal, and you could see a lot of garbage on the screen. When I switched the power supply to the low voltage 12 volt rails, it was a much cleaner signal and a much better display. All right, other than that, this ribbon cable here is the ribbon cable that originally went to this this connector here. As you can see, it's just cut off there, and I just put a a new header on here. I think this is a 20-pin header, and that's because that's what I had. So it's a little bit short, but it works. And then into a breadboard here to break that header out, and I could wire it into the switches and the potentiometers here for doing the signal level adjustments. This switch here is a 4-pole double throw switch, and that is used to bypass this amplifier when I switch it to this direction. When I switch it up towards the inputs here, it bypasses this amplifier and sends the signal straight from these BNC inputs directly to the input, the XY inputs to the scope. And when I switch it back down, it will place this amplifier in service. Now, talk about this time delay circuit here. This is optional. You may want to put that in or maybe not. It's totally up to you. But it's a very simple, just a TL or a, I think it's a LM555 timer with a transistor and a relay driver there. And it's set up for a delay after a delay after power on. So when power is first applied, the relay stays de-energized and the timer counts a delay. And after about 12 minutes or so, the delay completes and it energizes the transistor and closes in the relay. And when that happens, it puts a 22 kilo ohm resistor across the intensity pot, which is down there, and it dims the display. Here you can see the wiring from the display dimmer here, and it's just wired into the back of the intensity pot here. And then I've got a push button switch here installed, which was in place of this. I took out this phase control dial since I didn't need that, and it was only used in the vector mode and not the XY mode. So I took that out and put a push button in to reset the CRT dimmer. And of course you can push this at any time. It'll reset the delay, or after it delays or after it dims, you can push that to start to put the display back in full brightness. All right, here's just a quick drawing of the delay there for the intensity CRT dimmer here, and it's built around, like I say, built around a 555 timer. This is set up as a on after delay, so that when power is first applied here, we're using the 5-volt rail. It starts a delay. After the delay completes, the output of the timer goes high, and it closes in the relay here to dim the CRT display. The timing network is made up of a capacitor here. This is a 100 microfarad tantalum capacitor here, and a 5.1 mega ohm resistor here. There is a LED here which is on board. That's the green LED that you saw earlier. That LED is lit when the delay is still counting. So once the delay completes, this LED will turn off and this relay will close in. And that's just more of an aid, because it's such a long delay there when you're when you're setting it up, just to make sure that to give you a little bit of indication here of what the circuit's doing. Now I put this is a little bit not normal here. I put a 3 kilo ohm resistor here between the reset pin and the positive rail. Normally that's just a short for this type of circuit, but I thought I might use the reset here to add a switch that would defeat the delay. By holding the reset pin low, it will prevent the timer from timing at all. And so I included this 3K resistor here as a pull-up resistor, but I didn't end up not doing that. So anyway, you can evaluate whether or not you want to add that. For me, I'm not counting cost on this, so it was no big deal for me to just put that resistor in there. And for the reset here is just a 100 ohm resistor from the power rail to across this capacitor. When you push the switch, it discharges this capacitor to start the delay over again. Just a small 100 ohm resistor here, just to sort of minimize the discharge transient from this capacitor, and basically to so that I don't wear the contacts out here too much on this push button here. And then there's some filtering here, 100 megafarads and a 100 nanofarad capacitor here for power supply filtering for the 555 timer. All right, so I mentioned the power supply for the amplifier, and that's been through here through these leads that are twisted up here. And I used the regulated supply here on the analog board to get those powers, those voltages here. So this is the negative 11.8 volts, and there's a positive 11.8 volts here, and these are just off of a couple of LM337 and 317 regulators. And I really couldn't find a better place to tie them off, so I just tied them directly to the output pins of these regulators. And it's you know, there's really it's a minimal current load on the regulator, so it's not it doesn't cause any additional problems here. The input here we talked about comes in through the ribbon cable, and then these are the these gain pots that we looked at on the schematic. These gain adjustments here for the X and Y inputs, and those can be used to adjust your levels as needed. And I did have to adjust them to get a good display, to get the display where I wanted it to be, but not. I didn't want to have these, you know, on a maxed out all the way. So they're not maxed out all the way, but just some adjustment there. All right, let's take a look at some of the display here on the vector scope. As you can see, there's a little bit of extra lines here. And I think that has to do with the blanking. I wasn't able to really get, one thing I will say about this is I wasn't able to get the blanking to work very well from the spectrum analyzer onto this this display. And I think it has to do with, you know, that I'm kind of sort of rigging this vector display up to do something that it wasn't always intended to do. Now, I could probably dig into it more, but really this is more of a purpose-driven device here to get this up and running so that I can continue working on my project that I need this spectrum analyzer for. And as you can see, there's a lot of these little artifacts here, and like I said, I think that has mainly to do with the blinking. Like I said, the Z axis, which does the blanking for the spectrum analyzer, is not being input into this. But anyway, it's still pretty legible. The camera tends to make everything a lot brighter than it really is in real life. And let me see if I can turn the intensity down here, and you can see that you know, when I turn it down, and of course it looks really bright still on the camera, but in the room it's not quite so bright. But as you can see here, a lot of that stuff goes away. Still this dashed line here where the system messages come up, and of course we've got the beam resting here. I am slightly concerned that it may get some burn-in on this CRT here, but not so much that I really want to dig into it, because like I said, this is essentially just a this was a sitting on the shelf for parts unit that now has new life as this XY display. Now I'm gonna change those controls back on the back, and we'll have a look at what the screen does. So first thing I'm going to do is I'm going to go and bypass the amplifier. So when I bypass the amplifier, like I did there, you can see that our video got a lot smaller. So when I was originally working on this, and I set up the X and Y inputs, this is what I got. And you know, that's a little bit small. And of course, played around with the controls, and then trying the high gains. So I'm gonna turn the high gain function on now. All right, so there is our high gain inputs. So this is the XY input going into the high gain, but no additional amplification. As you can see, it's still it's bigger. You know, it's readable. You could read this, but it's you know, you want it to. You have this whole display here, so you really want to use the whole display, and that's why I went and added the amplifier. So when I put this back on now, and I'm going to turn the take this out of bypass and put it back on to the amplifier. Now I have to turn off the gains because I'm on the high gain. So we'll flip this back to the low gain there, and now we see that the display is back. And that's because, like I said, I have it adjusted for to fit in this window here, so that we get a nice full use of the CRT display. So I hope that you could find something useful out of this video. I know it's a short video and it's a little bit different than the videos I normally put out. But anyway, I thought it might be interesting to share for those of you looking for an option maybe for how to get an XY scope for something to use for like for example, maybe the spectrum analyzer or something else that maybe has XY outputs for doing displays. You like I said, you can get something like this, and you know, with a pretty easy little conversion, you can make it useful for you know, give it some new usefulness again. And of course, if you've got you know, like a spectrum analyzer like this with a dead display, then you can it's definitely good to have something. I don't have a dedicated XY display, so that's why I ended up having to go with doing this option here. And I'm going to leave you with a video with a shot of this, which is my current project. I'm not going to say what it is, but I'm sure some of you can guess at what it is, just looking at the rotary switches there on the back panel. But that project is in the works, and hopefully when it's complete, I'll have some more information for you on this, and we'll go into more detail on the construction here. But like I said, that's all for that right now. Be looking in the future for the repairs to this spectrum analyzer. It's been quite the star of videos, and it seems like it's going to have another video about it again when we get the repairs and get the display working on this one. I do have parts on order, but on the way, and we will get into exactly what happened and where the fault is, and some troubleshooting, testing of the fault, and then getting into the repairs. But anyway, that is all for now. Thanks for watching, and just stay tuned to the channel, and we'll see you next time.